Now, Sige says, research in virtual reality in education is a relatively young field, but in recent years it has shown considerable growth. Recent examples of the application of VR in undergraduate education have focused on the potential of interactive and immersive displays in order to make the interface for the learning experience easier and more natural to students. The development of an interactive and immersive technology inevitably has an impact on all aspects of undergraduate and graduate education. Students like you would be able to experience a fully immersive experience in simulating and interacting with the food, energy, water system in a virtual environment, which may encourage you to engage in deeper learning. And I've argued that for both the virtual reality food, energy, water system and the ETI field scale system that we built at Florida Gulf Coast to have relevance, students need to be able to manipulate parameters that mirror realistic interventions in another layer of reality, the application space of community and household regional resilience planning. Now, one of the problems of lab bench projects like we're doing at ETI is they don't easily scale up to the field. One of the problems with controlled field study projects is that they don't always scale out properly to environments where there are social, cultural, or political challenges. Ironically, in a properly gamified multiplayer VR simulation, one can actually get better verisimilitude with respect to the broader social and environmental dimensions than in the lab scale or field tests. For example, how do the aesthetics work for a neighborhood, for a homeowners association? How would the food, energy, water system integrate with existing water, energy, and food infrastructure in the community? What are likely risks regarding spillage or leakage or fluids or gases? How might the food, energy, water system be impacted by or impact local wildlife or domestic pets or insects or potential pests? Would there be odor issues or delivery management or operation and maintenance issues to contend with? Our virtual food, energy, water system might be better for answering some of those questions or for heuristically revealing new sets of questions that a lab or field trial may not elicit. But to make the virtual food, energy, water system impactful and truly interesting, students need to know that there is also an actual analog version in the real world that can solve real problems. Otherwise, the intervention seems merely theoretical at a time when there is an emergency, an urgency to implementing food, energy, water solutions to impacted communities. What the combination of the field food, energy, water nexus system and the virtual reality food, energy, water system can do, once we develop the game so that it can be scaled up and down and placed in situational, in situ context with real communities of interest, is enable refinements and tweaks of the virtual and field test models so that we can achieve the proper blend between what Scott 1998 calls techne, codified, easily transferable formal knowledge, and métis, intensely local genius that is uniquely situational. But to make the real field food, energy, water system at the ETI Field Lab at Florida Gulf Coast University and the virtual system in their Viper Lab serve that blended function for community application, we need to make both experiences available to the widest possible audience, and in particular to potential stakeholders who would be interested in applying and implementing the technologies as they mature to their own neighborhoods. One of the challenges we faced at Florida Gulf Coast and USF is making the simulations accessible to a wider public and enabling real-time interactivity by users who are not able to access either the field location or the Viper Lab. Over the years, we've experimented with sustainability meetups in platforms like Second Life and VR Chat, but the cost structure of developing permanent VR real estate has deterred full development. Since dedicated servers are so expensive, we turn to other cost-free platforms that enable students to build the food, energy, water nexus systems in geographically accurate landscapes and engage with each other and the technologies from wherever they may be online. The most promising of these so far appears to be the online kids gaming and world creation platform, Roblox, a Minecraft-type open-world sandbox whose online community has already created and made available many of the sustainability elements, windmills, solar panels, tanks, plumbing parts, that we need for our application, and they've also made available the programming for interactivity with fluids and particle effects. In Roblox, we can place our few models and immediately publish to the web, and enable students from FGCU and USF, and indeed around the world, to meet up and start working with the simulations immediately. What is even nicer is that the platform allows team editing, so that multiple students can meet in Roblox Studio and cooperatively change the landscape and build in new models, terrain, and functionality using a kind of Google Docs approach, but in a 3D landscape. The latest release seamlessly accommodates the Oculus and HTC Vive VR experience. Now, there are a few challenges that we'll face in our efforts to implement the VR View Nexus until we can close the current digital divides that seem to force a gap in understanding and motivation between those who've been able to afford the hardware, the software, and time to become digital natives, familiar with gaming as a tool for content learning and instruction, and those for whom this is a foreign and intimidating experience. Without strong leadership and guidance, it's not immediately clear that engineering or sustainability students will be able to realize the promises offered by this new educational paradigm. It isn't a given that digital natives themselves will immediately see how to apply their familiarity with digital tools to the educational arena unless we create the right context for them that can make them excited about the connections between real-world education and escapist gaming. Game designer Jane McGonigal, in her books and TED Talks, has stressed that young people are making a mass exodus away from school and reality, which she calls broken, precisely because the way we teach doesn't offer them much hope for the kind of tomorrows we're creating on their behalf in which they don't feel they can meaningfully contribute to. That's from McGonigal 2010. To achieve the epic win that McGonigal says young people are demanding, they need to be empowered with skill sets that can act as a bridge between super better fantasy world creation through digital imagineering and reality fixing through real world engineering. Even most hardcore gamers don't seem to know how to actually create relevant worlds that can help meet skill acquisition goals. They can be adept at building complex bases and shelters and crafting tools in sandbox games like Minecraft, Fortnite, and Rust, and Ark Survival, and even Roblox Building, but they have no idea how to apply those skills to bringing their own school sites, communities, neighborhoods, or homes to life. The foundational skills of digital engineering for 3D simulation and VR are lacking in most sustainability programs, as are many of the real-world engineering skills and tool use trainings. Minecraft uses Python, Unreal Engine 4 uses C++, and Unity uses mostly C# or JavaScript, while Roblox uses Roblox Lua. Conceptually, the use of these languages is very similar, and one doesn't need to be a highly qualified coder to use programming objects to make a functional game, but sustainability education still sees basic computer programming as a specialized skill rather than a core capability. And meanwhile, the translation between text coding, visual programming, and object creation, functionality scripting is being increasingly taken over by artificial intelligence and machine learning. At some point soon, these divides will be crossed, if only because a new crop of digital natives are growing up with free digital design tools and free online curricula and video tutorials that enable quick creation and instant feedback with AI that takes a lot of the burden off the creator and enables spectacular results. As the Roblox education site says, quote, "Educators, Roblox's creation tools and educational content are provided free of charge. As one of the fastest growing resources for educators, Roblox allows anyone to build and publish their own games while learning real 21st century skills. Students, anyone can build a game on Roblox. It doesn't matter if you're new to coding or you've never designed your own virtual world. With a little imagination and the right tools, you're already well on your way to taking the first leap into game development." What we must do in our schools is enable these powerful tools to be used in the local context and with an aim toward mastering the content of sustainability and the food, energy, water nexus with zero waste circular economy goals. We must empower our students with ways to reward their investment of time in applying gaming technology to sustainability goals and relieve them of the anxiety of having to satisfy both traditional assessment requirements, quizzes and exams that demand rote learning and memorization, and portfolio assessment demands, where a time-consuming and often cooperative creative product is required. As educators, we must also create focused tutorials that are content outcome driven and relieve the students of the burden of having to stumble blindly through a bewildering landscape of menu options, techniques, and multiple software packages in order to achieve desired results. Since the goal is to have productive stakeholder-driven conversations about realistic simulations and alternative scenarios for the sustainability of their futures in their locales, Our food, energy, water, tool environment needs to be developed in such a way that it provides a heuristic for asking the important relevant questions about landscape change and infrastructure decisions, and be able to visualize different outcomes based on parameters that can be interacted with and manipulated until everybody is satisfied with the results. VR gaming hardware and software allows for such precision and accuracy, as well as for flights of fancy. It's our goal to bring all of these worlds together to create a new form of education that inspires involvement by seamlessly blending the virtual and the real. Let's just do it.